Have you ever had to write code to handle a whole lot of data and do a number of different things with that data? No doubt the first thing that comes to mind is using a switch statement, but that's neither the fastest nor the cleanest way of handling such a problem. Stick with me and I'll show you how you can speed up your code and greatly simplify it by switching to the function pointer fast lane. In this example, we need to collect the total character count for only a subset of the characters in the data. We'll count the G's, A's, T's, and C's individually and lump all the other characters into an others count, and then print out our totals. We'll start off with a simple switch statement and simply increment each of the totals for the letters as we find them. Running this over a large data file takes about 9 seconds, so this is our baseline metric. However, the likelihood that this is all we want to do for each letter is pretty low. In my DNA-themed GATC processor, all of the processing is going to depend on each of the characters to execute commands and subcommands. So I added a small set of functions for each of the GATC letters that, for now, do the same thing, just increment the counters. Here in the switch statement, instead of incrementing the counters directly, I call each of the specific functions. Executing that, we see that it slows down the processing due to the function pointer overhead and goes about 5.5% slower, making this a more realistic baseline metric. This is where switching to the function pointer fast lane is going to greatly improve our processing time. First, we define our function pointer type as one that takes no parameters and returns void. Then we'll create a lookup table that contains function pointers for every letter that we will encounter, capital A through capital Z. Initialize the entire table with calls to the countOther function, and then we overwrite the table values for the letters that we care about. Now, instead of the bulky switch statement, we just look up the function pointer in the table and call it for the letter of interest, all in one line of code. Running this, we are now 11.5% faster than the original switch case code with the inline increment calls, and we've recouped all of the function call overhead. Looking back at the previous switch statement, it should be pretty obvious why this is the case. A switch statement breaks down to several compare operations. Basically, is it a letter G? No. Is it a letter A? No. T? No. C? No. Well, then it must be the default, which is the other. And since most of the letters are others than those 4, we've made 4 comparisons before we actually call the function for the majority of the letters. This becomes even more obvious when we add a bunch of additional cases to our switch statement. Running this code takes a whopping 17% more time than the original. In computer science terms, this is referred to as order in. Adding more case statements in increases the processing time linearly. By contrast, the function pointer lookup table operates in order 1, constant time, as there's already a case for every possible character. And to do something different for more cases is just a matter of changing the function pointer for the additional letters of interest. So there you go. It's a quick introduction to using function pointers to simplify and speed up your decision-making code. So next time you find yourself writing some gargantuan switch statement, think about how you could use function pointers instead. And as always, if you like this kind of content, please like and subscribe, and ring the bell for notifications. Thanks for watching.